Hi all, good evening. My name is Sandeep and welcome to my YouTube channel. Today we are going to fine tune DeepSeek-R1 model with our custom data. It's going to be a very important tutorial and important video. Please watch this video till the end. I will explain each and every step. So let's get started. So here we are going to fine tune this LLM DeepSeek-R1 model with custom data. So fine tuning of LLM is usually done with Hugging Face's transformers library, which demands very high computational power and memory. But for this tutorial, we are going to use Unsloth, a new library which offers a more optimized approach and making fine tuning possible even on slower GPUs. Like if you have very basic GPU also, you can fine tune your LLM on that also. So it reduces memory usage, speeds up downloads, and uses techniques like LoRA, that low rank adaptation technique, to fine tune large models efficiently with minimal resources. So for fine tuning any large language model such as DeepSeek-R1 here, so here basically we have fine tuned DeepSeek-R1 model, but in reality you can using these steps or this procedure, if you follow, you will be able to fine tune any other large language model. So for fine tuning large language models such as DeepSeek-R1, we need to understand some important parameters for fine tuning. So LoRA, LoRA. So LoRA is the low rank adaptation. It's a technique used to fine tune large language models, LLMs, efficiently, reducing memory usage and speeding up training by adapting only a small subset of parameters instead of modifying the entire model. So you don't have to deal with the entire model. You don't have to deal with all the parameters of the entire model. But here basically it is going to adapt only a small subset of parameters. So that way, there will be lesser memory requirements and things will be faster. So LoRA, low rank adaptation, adds trainable low rank matrices called adapters. Okay, so LoRA adds trainable low rank matrices called adapter to specific layers. To some specific layers, it adds low rank matrices called adapters. So what are the specific layers? They are some attention layers actually. So and then keeping the original model frozen. So it keeps the original model frozen, but it adds trainable low rank matrices called adapters to specific layers like attention layers, and it keeps the original model frozen while learning only a small set of additional weights. So LoRA basically decomposes this into, as you can see, the two matrices A and B, reducing the number of trainable parameters. So LoRA reduces the number of trainable parameters. So here you can see, suppose our modified weight W prime equal to W plus AB. The W is the original weight and that is frozen, original frozen model weights. And AB LoRA adapters. This AB LoRA adapters and small trainable matrices. So we are going to deal with only AB here. So model only updates AB, keeping W unchanged. The original, keeping the original weights, model weights unchanged. So it will only update A and B. Okay. So that way it has to deal with only A and B, two low rank matrices. So there are some parameters for LoRA. For example, R, this rank. So it determines the size of the A and B. So higher the R is, or the LoRA rank is, so more model parameters it has to deal with, more parameters. So better adaptation, but higher memory usage. Whereas if you keep the R lower, that is LoRA rank lower, then it has to deal with only fewer parameters, and so it will be more memory efficient, but may lose some accuracy, which is fine for the present study. Then there is another important parameter called load underscore in underscore 4-bit. It's a parameter used when loading the large language model in Hugging Face's transformer library, which we'll be using here. So while loading any large language model in this Hugging Face transformer library, there is an option that you can set it to true, load in 4-bit. That is basically uses the 4-bit, it enables the 4-bit quantization. So by enabling 4-bit quantization, basically things will be reduced. So it will basically it reduces the memory usage while maintaining the good performance. So it uses the bits and bytes quantization, so enables the 4-bit quantization if we set it to true, load in 4-bit. So there are several other parameters which I'll show you later. For example, the target modules. So the target modules parameters in LoRa specifies which layers in the model will be modifying using LoRa adapters. So using LoRa adapters, what are the layers which will be modified or trained basically. So target modules here like Q pros, query key, K underscore pros, key value V pros, O pros, etc. Get pros, up pros, and so on. So these are the basically layers in the model which will be modified using LoRa adapters. So this is crucial for efficient fine tuning because it reduces the memory usage by only adapting certain parts of the model instead of the entire model. Okay. So Q pros, K pros, V pros, O pros, these layers are part of self attention in transformers. So they are the part of the self attention layers. So adapting them allows the LoRa to modify how the model attends or pays attention to input tokens. Okay, similarly, gate pros, up pros, down pros, these are layers, they are part of the feed forward network in transformer models. So applying the LoRa here helps adapting the non-attention parts of the model. So that way it covers both the attention as well as non-attention part, and therefore improving overall fine-tuning results. So in LoRa, low rank adaptation, there is another parameter called LoRa alpha. That is a scaling factor that controls the influence of the LoRa updates on the original model weights. That means basically it controls the effect or the influence of the LoRa updates. So how much effect or influence of the LoRa updates will be on the original model weights. So that scaling factor controls. So this scaling factor balances the effect of the low rank adaptation so that the model does not overfeed or destabilize. So that is why it is very important, this scaling factor. So in the context of low rank adaptation, there is another parameter which we are setting to false that I will show you later. They use residual LoRa. That is a parameter related to specific extension of the LoRa method. RS LoRa, the residual LoRa, that anyway we are setting it to false, so I am not talking about it. Then there is a very important thing called SFTTrainer, that is supervised fine tuning trainer, which is typically part of the frameworks of supervised fine tuning of the large transformer based models. So supervised fine tuning, so it's an implementation that simplifies the process of fine tuning the pre-trained transformer models on specific supervised tasks. So supervised fine tuning trainer basically is an implementation that simplifies the process of fine tuning the pre-trained transformer models, any pre-trained transformer model or large language model on specific task or supervised task or domain. So based on our level data, custom data, so it is going to fine tune that actually. So supervised fine tuning. So SFT involves training the model on level data to adapt it to a particular task like classification, translation, summarization. So particular task or domain based on our level data, custom data, it will do it, and by adjusting the weights of the pre-trained model. So it's a part of this SFTTrainer, that is a part of when we'll be importing it from the Hugging Faces TRL library, that is a transformer reinforcement library. Then PEFT, that parameter efficient fine tuning, that technique that we are going to used to fine tune the large language model LLMs efficiently by modifying only a small subset of models parameter instead of all the parameters, which I have already explained. That here basically it will be just fine-tuning our large language model. In our present case, it is DeepSeek-R1 model. So here it will modify only a small subset of the model's parameter instead of all the parameters of the entire model. So it's a parameter efficient fine-tuning. So this dramatically reduces the memory and computational cost, making it feasible to fine-tune large models on consumer-grade hardware. So in our present study, what we are going to do, we are going to fine-tune this our DeepSeek-R1 model with our custom data. Here, as you can see, the mental health counseling conversation data is there. I already downloaded it locally and I went through it details, so I'll show you. So this is related to mental health counseling conversations level data. So with this custom data, we are going to fine tune it, and also we are going to test it or evaluate it with various mental health related queries. So it's going to be very interesting. So if I show you the data, I already downloaded it. You can see that basically there are columns like context, response, and conversation. This is in a GPT format, shared GPT format. This format is called. So here, as you can see, the human is saying whatever context I am going through some things with my feelings and myself. I barely sleep and I do nothing but think about how I am worthless and how I should not be here, something like that, blah blah blah. And so in the response here, whatever you can see here in the GPT, so that is coming from the assistant, or that is the response. So so GPT is saying that if everybody thinks that you are worthless, then maybe you need to find people to hang out, and so it is giving some suggestions, advice. So mental health related conversations between the human and then this assistant. Here is the shared GPT format. Now let's switch over to Jupyter Notebook, means basically Google Colab. So for this training, I have used my free Google Colab account, and in the Google Colab, so you can make sure that you set it to GPU. This T4 GPU is freely available. So before starting your training, just make sure that you switch to you are using the GPU or free GPU available, because that is a must. So what is the first step here? Fine tuning the DeepSeek-R1 model with the custom data. So first step is the required installation of required libraries. So as you can see, there are several libraries such as Unsloth, Unsloth_Zoo, Torch, PyTorch, the Torch Audio, Torch Vision, lot of other libraries. So make sure you install each of them like the way I have done it. The same versions you have to use here. The combinations of these library versions you have to install. Make sure they are installed properly. The next step is loading the original model and tokenizer. So for that, we are from the Unsloth, we are importing the fast language model, and also we are importing Torch. So here define configurations for loading the model. So what are those configurations? So maximum sequence length. Maximum sequence length is 2048. That is the maximum sequence length of text actually that we are setting. Then data type none, that is automatically that will be chosen. So either be like float 16 or be float 16. Then load in 4-bit, that I have already explained. I set it to true because it enables a 4-bit quantization to reduce memory usage. Okay. Then here we are basically loading the model and tokenizer, the original model and tokenizer. That is using the fast language model dot from pre-trained. Here you have to specify the model name. In our case, it is the DeepSeek-R1 Distill Llama 8 billion parameters. We are basically this model we are going to fine tune. Okay, DeepSeek-R1 Distill Llama 8B. Okay, and with the help of Unsloth, we are doing it. So maximum sequence length equal to maximum sequence length, which we have specified here. Data type equal to data type. Load in 4-bit, load in 4. Okay, so loading the original model and tokenizer, you understood. It is done. Then next step is basically we are going to test the original model with some mental health related query. So we have to first see how the original model performs. If at all it is able to address the mental health issues or mental health related query. or not, whether it makes sense. So then we'll do the fine tuning later, and I'll show you the effect of the fine tuning or training. So test the original model with the mental health related query. Okay. So here from Unsloth.chat template, they import get chat template. Then tokenizer equal to get chat template. Here pass the tokenizer. Already here we already loaded the model and the tokenizer. So here we are passing the tokenizer. Then chat template, some particular chat template version we are using. Only template, so that is Llama 3.2 chat template version we are using here. Get chat template tokenizer, and then set the PAT token to be the same as the US token. Okay. So the PAT token, you might be familiar with this. So you have to here set the PAT token here. Otherwise, there will be tokenization issues. So you have to set the PAT token to be the same as the US token. End of sequence token. So here we are doing that, and then we are setting the model for inference, first language model dot for inference and model. So then we are giving a message from the user. So role user content, I am mentally very upset because I failed my job interview today. So this is the message. So inputs equal to tokenizer dot apply chat template. So we are applying the chat template, the tokenizer, and then passing the message tokenize equal to true, and then setting other things. Return tensor equal to PyTorch tensors instead of numpy array. So return tensor will be by PyTorch tensors only, and then padding equal to true. So adding pad to match the sequencer, there will be the sequences of varying length. So in order to make it unified, so we are adding padding here, padding to match the sequence length, and then dot to coda. So then attention mask equal to input not equal to tokenizer dot pad token ID. So it will ignore all these pad token IDs because we don't need that. It doesn't need. So it is filtering. Basically, it will exclude this tokenizer dot pad token ID for inference here, and then output equal to model dot generate. We are passing all these input IDs. Attention mask equal to attention mask. Maximum new token will be 64. Use cache for the faster token generation. The temperature is pretty balanced, 0.6. Controls the randomness in the response. So don't make it too random. Let's keep it 0.6, and then minimum P 0.1. And then finally, after getting the outputs, we are basically decoding it. So text, we are getting the human readable text here. Tokenizer dot decode. Then we are passing this output 0. And then we are printing the text. So this model is not at all fine-tuned. It's the original model. So it is saying when your user is sending this query, I am mentally very upset because I failed my job interview today. So it is saying, I'm really sorry to hear that you had a tough job interview experience. It is completely normal to feel upset after something like that, and why don't you try to talk about how you are feeling? Sometimes it is just sharing your thoughts can help you process your emotions if you want, blah blah blah. But it is not that way. It doesn't make sense. I mean, it's a very generalized response, and it really doesn't address the mental health issues or the person's mental health conditions. So it's not a very practical suggestion or advice which will address a mental health issue. So now we have to proceed with the training or fine tuning the model. So for that, apply the LoRa adapters for efficient fine tuning. So model equal to from fast language model dot get PEFT model. So we are using parameter efficient fine tuning. So dot PEFT model. Then we are passing the model. Already we uploaded above. Then I already explained LoRa rank. So we are specifying LoRa rank. We are keeping it low rank S16. Then target modules. These are the layers we are going to apply LoRa adaptation. These are the layers I already explained. LoRa alpha I already explained. Scaling factor. Then LoRa dropout equal to 0. We're not going to drop out anything. So bias equal to none. Then use gradient checkpoint Unsloth. We are doing it through Unsloth. Random state is random state, random seed, etc. All these things. So 3407, so that by running the same script, you will be able to reproduce the same results. The use other things are already set. Use RS LoRa, that is false. So it's done applying LoRa adapters. Then after that, next is prepare the training dataset. So from the dataset, import load dataset. Load data from the Hugging Face Hub, we are loading. We are basically importing the load dataset from dataset load dataset. Then dataset equal to load dataset. Then what dataset are we uploading here? So that is the Sulabh mental health counseling conversation, which I already showed you, that one, and split is train. So that dataset we have just loaded here, dataset. So we have the dataset now, but that is in the shared GPT format. So now next step is the convert the data set from the shared GPT style. Shared GPT style, from value, all these are there, to Hugging Face, generic format we have to convert. That is role content. This kind of terminologies will be there, role content from value, etc. So for that, from Unsloth.chat template, import standardized shared GPT. So this standardized shared GPT utility will be using in order to convert the dataset format from the shared GPT format to Hugging Face standardized. So Hugging Face standardized format, we need this format for this dataset for training. So this will be from value to role content. Okay. So dataset equal to standardized underscore shared GPT, and then passing the dataset, so it has been converted. So I'll show you some example. A dataset entry in the shared GPT format. Shared GPT format here, something like the from system value, you are an assistant. Then from human value, what is the capital of France that user is asking, the human here. So from GPT, that is assistant value, the capital of France is Paris. So we are converting it to role-based Hugging Face format. So here wherever you see the from, that will be converted to role. And then system will be will remain a system. The human will be converted, will be changed to user. Human will be changed to user, and then GPT will be changed to assistant. Then wherever you see value, then they will be changed to content. Other things will remain same. Data will remain same. All these things are all these terminologies will be changed here. So now it is in the Hugging Face format. Data is in. So now the next step is format prompts. This is very important. Once the dataset is prepared, now it is in the Hugging Face format, but we need to ensure that the data is structured correctly to be used by the model. Data is structured correctly to be used. The structuring is very much structuring of the data. For this, we apply the appropriate chat template. So, and here we have used the Llama 3.2 format. Those appropriate chat template we have to apply, and using the get chat template function. This function basically prepares the tokenizer. So the tokenizer, it will prepare the tokenizer with the Llama 3.2 chat format for the conversational style of fine tuning. So in our case, it is conversational style of fine tuning. So that is why it is very important to convert the structure of the data set using the this chat templates, Llama 3.2 chat template. So we have to apply the basically we will prepare the tokenizer with this chat format, Llama 3.2. Okay. So from Unsloth.chat template, so you have to import the get chat template. Okay. Then apply the Llama 3.2 chat template to the tokenizer. Tokenizer equal to get chat template, and then we are passing the tokenizer already above. You must have seen the tokenizer. We are passing it, and then you have to specify the chat template format version. That is a Llama 3.2. Okay. So once you have the tokenizer here, then function 2, we have to write a function to convert the data into tokenized text. So we have to convert this data into the tokenized text. So for that, we are writing the function formatting prompt function. We are passing the examples data. So conversation equal to examples conversation. So conversation data you have this, and then here you are converting it to the tokenized text. This line, here you are converting it to the tokenized text, and then you are returning it. Once you have the function, then you are applying the function. You are mapping this function on and applying it on the entire data set, so that entire data set data can be can be converted to this tokenized text. So here we are doing this in this line. Data set equal to dataset dot map. Then this we are passing this function, the formatting prompt, and then best equal to true. So that is done. So now our training data is in the tokenized text format. It is ready for the training. So now if you print the just at least one item in the original conversation text format, and also after converting it to the tokenized text, how it looks like. So you can see the original one. Here you have the content. I am going through some things in my feelings and myself, whatever it is there, and then whatever is coming from the assistant, the role content, all these things, and then after converting to the tokenized test, it will be something like this here. The start header user, end header id, start header id. I am going through the data will remain same. Only thing is that the structuring is different here. Structuring. So once it is structured properly, it is ready for training. Now next step is the setting up and configure the trainer. So configure the fine-tuning process using the Hugging Face's SFTTrainer. It automates the key tasks like tokenization, batching, optimization, etc. So making the fine-tuning easier, and the SFTTrainer works efficiently with the Unsloth, reducing the memory usage and speeding up the training. So for that, from the TRL, which is a part of the Hugging Face, import the SFT supervised fine-tuning trainer, and then other things also you import, and then you have to here all the define the training configurations. All the training configuration is for the SFT trainer. Model equal to model, pass the model tokenizer, all these things, everything, maximum sequence length and data set number, processors number, processor, all these things you pass, and then argument equal to training arguments, then number of examples per GPU batch, all these things, all the parameters you have to set. Then warm up steps equal to 5, then maximum step equal to 0, because we are going to run one entire epoch. Okay, here in this case we are going to run one entire epoch, but in reality if you don't want to run entire epoch because it is pretty time consuming, memory consuming, you can just run it for few steps also. But here we are going to run entire epoch equal to 1. Learning rate 2e minus 4. Then other things are there already. AP16, it will just check whether it is supported or not, or then accordingly. Then logging step equal to 1. Then optimizer Adam W 8-bit optimizer is weight decay 0.01. The regularization parameters. Then random seed also 3407. Enter the output directory. Everything is here defined. Okay. The next step is training on the assistant response only. So notice here we are going to train on the assistant response. Here it will to improve the training efficiency and to make the training faster, we'll focus only on the assistant response rather than user input. User inputs mostly will be ignored, but the assistant response, based on the assistant response, it will train it. So for that, from Unsloth, the chat template import train on response only. So that is why we are using the train on response only, because we'll be training only on the assistant response. Okay, then trainer equal to train on response only, and then you pass all this like trainer we defined here above, trainer, and then instruction part, that is start header id, user, end header id, mark user input. Okay, and then response part, start header id, assistant, end header id, mark assistant response, but mostly it will train on the assistant response only. So then you're for starting the training, trainer.train, that's it. Just trainer.train do, and it will start doing the training, fine tuning. So in our case, basically one epoch, we trained it for one epoch, and 400 and something, yes. So it is 439 steps it fine-tune the model, trained. So after that, we are going to test it, this fine-tuned model, with the same mental health query. So in the inference part here. So same thing, same user query or user content here, role user. I am mentally very upset because I failed my job interview today. Now we are going to evaluate this our fine-tuned model, and we are going to check the response, what it says, what suggestions, advice it gives, and how it addresses the mental health issues. So this is the response, and it really makes some sense, So that means our model training, this fine-tuning has worked. Though we have done it for only one epoch, but in reality, you can do it for many epochs. If your time and memory permits, you can do it, and you will get much better results. So, but it is what we are getting, it is making really sense. It is hard to know whether or not you will get the job. Very practical. It is very hard to know whether or not you will get the job. I would suggest that you give yourself some time to rest and recover from the stress of the job interview. It's very practical suggestions. I would also suggest that you look at the situation in the new light. you look at the situation in a new light, such that what you learned from the interview process and how you learned, like what interview from the interview process, what you learned, what is your learning experience from that, that would be beneficial for you in future. You look at the situation in a new light, and you it is also giving very good suggestion that you should take some break to take rest and recover from the stress of the interview. So as you can see, it is our this training or fine tuning has some effect here. It is making sense. And if you want to save the model, so here you can, that way, this way you can save my model equal to, just give some name, then model dot save preprint my model. So locally you can save. You can also push the model and save it to Hugging Face also. You can push it to Hugging Face also. That is there. And I did some more testing also with other queries also. I'll show you here. Similar kind of query, but slightly different. For example, here, this is before fine tuning. I sent a query. I am highly upset because I failed my maths exam. And before fine tuning, it said the response that I got from the LLM, DeepSeek-R1 model, but it is not yet fine tuned. It is the original model. I'm sorry to hear that you are feeling upset about your maths exam. Maybe you made a mistake somewhere. This is ridiculous. But don't worry. There are many other ways to improve your math skills. You could ask for help from a teacher or tutor, maybe join a study group. But these suggestions, they really don't address, the mental health issues or problems, the mental condition of the person, what he or she is going through. So that means it is not a trend with the mental health related conversation or data. So after fine tuning, the same query, I got this response. It is important to understand that failing an exam does not mean you are a failure. This is a very bold statement. That's very meaningful and impactful. It is important to understand that failing an exam does not mean you are a failure. So this will give some mental support to the person. We all have moments of not doing our best. We all have moments of not doing our best. It is also important to understand that failing an exam is not a reflection of your ability to succeed in the future. This is amazing. So it is important to understand that the failing an exam is not a reflection of your ability to succeed in the future. So definitely some person will feel better after reading this response, and it will give some mental support to the person. So that way the fine tuning works. I have fine tuned it only for one epoch, but if you do it for more epochs, definitely you will see more results. Okay, so that is all for this video. I hope you enjoyed it and liked it very much. If you like it, please give a thumbs up, and also please give your comments or feedback. I would really love to see them. And please also subscribe my channel. I am going to create more such interesting videos in the near future. Thank you very much for your time. Thank you. Bye.